Hello friends, in this one, let's take a look at answering some questions about series, whether they converge and diverge. So here are some examples. This is the sum here as n goes from 1 to positive infinity of 1 over k to the n, and we're told that k is greater than 1. So first of all, notice that that's the same as writing that, basically it's a geometric series. It's as if you had a r equal to 1 over k, and k, for example, since k is a number like 5 or 2 or 10, then it would be like a half or 1 over 10. Or maybe k is 90, right? Because we're told k is greater than 1. This would be 1 over 90. Each of those values would be less than 1. Or roughly speaking, it would be like saying, when k has the value 2, you would end up with the summation from 1 to infinity of 1 over 2 to the n, you see? Okay, for the next one, take a look. It says the summation from 1 to positive infinity of negative 1 raised to the n. But notice negative 1 is not on the parentheses, so that means you can pull it outside the sigma symbol as a constant, negative 1. And then add up the part from 1 to positive infinity of 1 to the n. But of course, anything 1 that is raised to the n is just 1, correct? So it becomes negative, and then 1 plus 1 plus 1 plus 1 plus 1 forever many times. So in the end, basically, you would end up with negative infinity. In other words, it diverges. That's a way to think about it. Okay, for the next one, it's going to go from 1 to positive infinity, and the term is sine of n over n plus 1. So again, the way to think about it is you want to take a look at the limit of the nth term, so to speak, and see whether it's converging to 0 or not. So in this case, let's take a look. So limit as n approaches positive infinity of sine of n over n plus 1. So the sine function is continuous. That basically means you can slip the limit inside it. So it becomes sine of the limit as n approaches positive infinity of n over n plus 1. That inner limit, well, when n is a huge number, then the 1 becomes irrelevant. So this just becomes basically n over n, which is 1. And the limit, that's true. So you end up with sine of 1. Now clearly sine of 1 is not 0. So this basically tells you by the test for divergence using the nth term that the series diverges. That's what it's telling you. Because ultimately what it's saying is you would end up adding a lot of values that are sine of 1. That's some number basically that's not equal to 0, so when you add up a lot of them, your sum there will diverge. Let's look at this last one here. So we have summation here of 1 to positive infinity, negative 1 raised to the 2n. Be careful because now the negative 1 is inside of parentheses. But look at some values here. So when n has the value 1, this is negative 1 to the second, because it's 2 times 1, which is 2. Next one, when n has the value 2, you have 2 times 2, which is 4. So it becomes negative 1 to the 4th. When n has the value 3, it's negative 1 raised to the 2 times 3, which is negative 1 to the 6th. Notice that each of these exponents, 2, 4, and 6, is an even number. So negative 1 squared is positive 1. Negative 1 to the 4th is positive 1. Negative 1 to the 6th is positive 1. You can add up infinitely many 1s, and you'll end up, therefore, with infinity. In other words, the series will diverge, naturally enough. That's it for this one. I hope it's been helpful. Please leave a like and subscribe. Thank you so much for watching. I'll see you in another video.